Hello, my dears. It appears that this problem on your homework requires a little bit of help. There is nothing wrong about that. We have three charges arranged as you can see in this diagram, and they have positive charges and they're equal. You have each one to be equal to Q. And they give us that the string right here is 30 centimeters. This one obviously is not quite 30 centimeters. We are asked to figure out the value of Q. They are all equal, but we just don't know what it is. Look how they're so sweet to remind us that there's force of gravity acting on those all three charges because they have a mass of 100 grams, so 0.10 kilograms. Also know that this angle right here is 45 degrees, which tells you that when you look at the forces, like this distance equals this distance, so forces might be equal. But let's take, before we do anything else, let's draw a free body diagram. For the one in the middle, it's all nice and easy because it's going to have force of gravity straight down and it will have force of tension straight up. Those two forces are going to balance each other out. So tension, gravity on this one. Also, the charge on the left is going to repel it with electric force, and the charge on the right is going to also repel it with an equal force. So the charge in the middle is just chilling. It is in equilibrium. All forces are balanced out. While the charges on the right and on the left of the middle one are also in equilibrium, but the forces are not all quite the same here. Force of gravity straight down, same. Force electric, there's not one force electric, right? Because it is affected by, I'm going to draw one force and another force right next to it, just to distinguish that there are two of them. And we also have force of tension along this string. And remember, because it is at equilibrium, that means that the forces are balancing each other out. Which forces are we going to talk about? Well, force of tension, as you can see, is acting in two directions. So I'm going to say that this is force of tension Y, and this is force of tension X on the charge on the right. And then I'm not going to waste my time drawing forces on the charge on the left because they're going to be identical, just in the opposite direction horizontally. Let's check. Force of gravity would be mg, and it should be equal to, opposite in direction, but equal in magnitude, to tension Y. Force electric 1 plus force electric 2. I'm going to say this is 1 and this is 2. The two of them together should be equal to tension X, because tension X is to the left. So this right here would be tension X. This dotted line right here would be tension X, and this dotted line right here would be tension Y. Then this tension Y is equal to mg. And then see, remember how I said that there is a 45-degree angle, which means that this being 45, that is also 45. That means this side and this side, they're equal. They're congruent. In my triangle for T, I have Tx and Ty. This is Ty. This is Tx. Tx equals Ty. Mg and these two forces. Mg should be equal to F electric 1 plus F electric 2. Now let's look under the hood. What are these F1 and F2? They both will have Kc in them, because remember, what is electric force? Kc, and then we have the absolute value of Q1, Q2 over distance squared between those two charges. So Kc is going to be in both of them. And Q, every time it's the pair of Q's, so it's going to be Q squared. What is different here is the distance. So I'm going to have 1 over, what is the distance between? Let me clean it up a little bit so we can take a look-see at the distance between the charges. This is given to us to be 30 centimeters, so that's 0.3 meters. This is 45 degrees, so then this is going to be L times sine of 45, which you remember is root of 2 over 2. Right there. This distance right here is L roots of 2 over 2. Or you can also think about it as L divided by root of 2, if you are comfortable with that. And the distance between this pair of charges is going to be twice that. So it's going to be 2L roots of 2, or you can do 2L roots of 2 over 2 if you're more like that. So kind of something like this. So let's look at what we have then. We have 0.1 times 9.8 should be equal to 8.99, 10 to the 9th, that's Kc, Q squared. And then over here I have 1 over 0.3 squared divided by 2, and then plus 1 over 4 times 0.3 squared times, now this is divided, sorry, that is divided divided by, so then we have 0.98 equals about 249.7 if you want to carry those significant figures, times 10 to the 9th. That is times q squared. So then you divide 0.98 by 249 10 to the 9th. Remember to put parentheses. And then you're going to square root. So the answer is the charge on each of those particles is 2 microcoulombs. Q equals 2 times 10 to the negative 6 coulombs, or if you're so inclined, 2 microcoulomb.